welcome back to the Automation on YouTube channel. In today's video, I'm going to demonstrate how to use PID control blocks to maintain the process temperature within the set point. For this demonstration, I will be using the Siemens TIA Portal along with the S7-1200 PLC, KTP400 HMI, and an IFM temperature sensor. But before we begin, please like, share, and subscribe to our Automation on YouTube channel. Alright, let's get started. First, you need to open the TA portal. Here, I have already created a project using S7-1200 PLC and KTP400 HMI. Click on the PLC and expand it the program blocks. Double click on the main OB. Also, I have a small program written here to start up the PID, and I have already scaled the analog inputs. In this video description below, you will find the link to the previous videos on how to create new project in Siemens TIA Portal and how to scale the analog inputs. If you are new to this, I will recommend watching those videos first to get familiar with the basics. Okay, let's move on to the program. So since we are going to use the PID control blocks, we need to click on the technology and go to the PID control and click on the compact PID. Here you can see there are PID control blocks. For now, we're going to use the PID compact. For to use the PID compact control block, we need to add a new blocks in the program blocks. Double click on the add new blocks and click on the cyclic interrupt block. So this is the block that designed for mainly for PID controller and where the calculation all required. So you can name it whatever you want. Okay, you can name it as a PID. Since we are going to use for PID, so we can name it as PID controller. And the cycling time in the millisecond, you can adjust it accordingly or the requirement of the process. For now, I keep it with the 100 millisecond. Then we click OK. So the PID control block is ready. Now we have to drag and drop the compact controller into the control blocks. Okay, click on the compact PID. Here is the PID compact. Click and drag and drop here. So you can name it PID controller. Click OK. So this is the PID controller. Now we need to assign the inputs and outputs to use the PID control block. The inputs are set point and input peripheral. Click down and then you can see there are some other inputs like manual node, manual value, and then here is the output. This is output peripheral, output PWM, and state error bits. All those they have. But we're going to use some of the basic inputs and outputs to use the PID control block. So for now, we will set the set point. Write it with name as a temperature underscore set point. Okay. Click, right click and then define that. Click to global memory and the address will automatically assign. If you want to change the address, you can click it and then you can change as per your requirement. But for now, I will keep it the auto assignment. And click define. So the address is designed for the set point. Next one is input. So here there is two things. One is input, another one is the input peripheral. If you are scaled or analog input, you can use the input. If you are not scaled, then you can use the input peripheral. But we have already scaled in the menu OB my analog input. This is my analog input IW64, which I scaled and converted to 0 to 100 minimum and 0 to 100 value. So here is the temperature real value. So I'm going to use this as a my input. So this is a my input, click in temperature real value. So this is my input. Then next, this I'm not going to use since I'm using this one. The next one is we can use manual mode. So for this, we can click manual mode, define, that, click on the global memory and let it automatic assign of the address. Then define. Next thing is manual value. Name as a manual output. Click on the global memory and define. Okay, now it's manual output is ready. Then we go move on to the output. Here there is a three types: output peripheral, output PWM. But for now we're going to use output peripheral, which I have not scaled. So I will use this output directly from the PID output, PID controller. Find tag same as previously, global memory automatic assign you can define. Okay, that's it for now. We have done this assignment for the PID control blocks. Then next we need to configure the input and outputs into the PID control blocks. For this, you need to click the technology object and click on the PID controller, and here you can see there is a configuration. So double click it, then the page, when you open it, you can see how the controller types. So we are going to control temperature, so that we can click select the temperature, and then what mode we are going to use. We are going to use a automatic mode, so you can select it automatic mode. The next is a input. So what type of input we are going to use, we already assigned as a input, not this. So we select input. Output is we're going to use this output peripheral, which is already scaled within the block. So we're going to use this. So leave it with this. The next is go to the settings, the process value, high limit or low limit. We already set the low limit, high limit in the program, which is 0 to 100. So I'm going to change from 120 to 100. That's it. This is disabled because we are not using this option. Then click the advanced settings. Here nothing much for me to change. The output value limits is already 0 to 100, so I'm going to use this the same set points. So nothing else to change here. uh, if you want, you can enable the manual entry, so that you can manually change these the proportional and integral and derivative values for to tune your PID control blocks. So you can click it if you want. The controller structure type, there are two type of structure. One is the PI and another one is the PID. So you need to select which process is required. For me, I'm going to use the PID now. Okay, that's all. We have done this part. Now we're going to the HMI section and do some graphics and for visualization, and then we can download the program to the PLC and HMI, and then finally we do the commissioning of the PID controller. So you go to HMI section, expand it, expand the screens, double click on the PID screen. In this video description below, you will find the links to the previous videos on how to create the projects within the Siemens TIA portal. So please watch it to create the buttons and then IO fields in the HMI section. So now we're going to use some of the IO fields and the elements here. So for the elements, maybe we can use this to visualize the PID output and the manual output of the PID control block. We click on the properties. So we go to the layout first to set the specific size. Maybe we can the size. Maybe we can put it somewhere 55. Okay, 155. Okay, that looks okay to me. And go to appearance, colors. I found colors. I just changed to green color for the PID output. Go to gentle. That's okay. This already we set 0 to 100, and then you click the. You need to link to your PLC text default tech table and go the scaled output. This is the scale output. Okay, next one. Appearance. Is there any changes in the appearance? Okay, the border is so thick, so maybe we can reduce to smaller size. Okay, now looks okay. So we copy and paste for so that we can use for this to manual. Okay, from manual output. Click here and then click this and go to PLC tags default tech table manual output. So we can display the manual output here. Click on the appearance to change the color so that you know it's on the manual. Okay, this one is the manual. You position it so just move towards up. Okay, that's okay. That looks okay. Looks everything okay. So here's the temperature. Then next one is the set point temperature. So okay, set point. You need to assign the tags to the right tag. Click on here and go to the PLC tags default tag table and go to the temperature set point and click OK. So now we assign the IO field to the set point temperature. Then next one, if you want to display the output, so copy paste it and move to here. Just change the name of this to PID output. PID output. Then you need to assign this to the relevant tag. So you go to PLC tag, default tag table, and go to the scaled output and click OK. This is the our PID output. We paste it. We can use this for manual output. Assign to the relevant tag, PLC tag table, and go to the manual output. Click OK. That's it. So now as it's ready for to change to manual mode, you need a button to you need you need a two button to select from auto to manual. So I will create a two buttons here. So one is I can name as auto, one is manual. So key manual. Okay, if you want to use the auto manual mode, so also you need to write a simple program to switch from auto to manual. So for this, we will go to the PLC program and write a simple program. Okay, you go here, then we write it as an auto manual control. Okay, this one we can change to, we can rename it as a PID on. Change. So now when you press the start button, the PID is on. When the PID is on, okay, PID is on, then you can press the manual button to turn on the manual output. So manual underscore push button. I use the push button. So I just name it push button. Redefine tag, global memory, and click define. This output as a manual mode. We already have a manual mode selected. Now, if you want is the direct PID output, so you need to stop the manual mode. So we latch and then stop. So you press the manual push button, the manual mode is on, then you need to latch with the manual mode and you need to cut off the manual mode when you use the auto push button. So when you click the auto push button, this manual mode will cut off and then go to the PID control mode. So now we have ready this manual push button, auto push button. So we gonna assign it to the HMI screen here. Then we click auto, define tag, go to the properties, tag events, press HMI, click here, and then go to the PLC tag, default tag table, auto push button, click OK. This one same as before, assign to manual push button, click OK. So that's all. For the manual entry of the gain and the integral and the derivative values, you need to have the IO field, so that I will copy a few of these and then I can paste it. That's the gain. Another one is derivative. So So for this, go to the properties and assign the tags to this and click here and go to a technology object and go to the PLC and under this retain control parameters, here you have this gain and click OK and same as this there and then click to the technology object and the PLC retain and control parameters integral and go for this, click on this and builds technology object PID control and go to the retain control parameters DD, which is the derivative time. Click OK. Okay, that's it for now. We have done our visualization in the HMI side. We have to download the program to the PLC and the HMI, and then we do the commissioning in for the PID control. Alright, we will download the program to the PLC. Click on the PLC and click on this download to device button. Click on interface. So I'm using a Realtek SP. Click on this and click direct slot start search. Okay, the PLC is here. So click load the program. Click to stop all and load. Click finish. I open your main OB and then you can monitor the values whether your program is ready to start. Okay, as you see here, so you have all the green dots, which means your offline online program is same. So now you can see that our temperature sensor is connected to the PLC. It's reading 29.2 is the current process value from the temperature reading. So the PID is not turned on until now. The manual mode is off. This is our program, and then you go to the PID control, and then here is the PID control block. So here you need to add one point to on and off the PID controls. For this, you will click here and then add a button PID on. This PID on need to download the program. Load. Okay, I can monitor this. Okay, now the PID is not turned on. Okay, now PLC part is completed and we move on to the HMI section. Click HMI and download. Select interface, uh, Profinet, and then go to Realtek USB, direct and start search. Okay, the HMI device is here, and then click load over program. Click load. You can see that we have already downloaded our program to the HMI section, and this is our PLC, and here is the temperature sensor. You can see the temperature value is 29.3. Now we can do our commissioning. Go click on the commissioning. Okay, for now we need to turn on the PID first. So for this I will press this button to turn on the PID. Now the PID block is turned on, and then we need to do the commissioning on the side. So here as the this is where we need to do the commissioning. Here you can see the current set point, schedule, scaled input and the output. So okay, start. You need to set to a set point to I'll set my set point is 65, and then click enter. So now we set the set point. Here, acknowledge. Okay, we need to do the pre-tuning. Click on the start. So now our input is 29, our set point is 65, and then the output is displaying 100%. So we need to, when the output is open, then you can see that the temperature increasing to 52. So you can see that the system is tuned. So you need go to the PID control blocks and then see that output. The output is 100%. It's opened, and the temperature set point is 65. The temperature real value is 45 now, and that's why the output is open 100%. If your temperature goes high, to see your output is slowly decreasing to 91, which means is controlling the PID controller is controlling the output according to a temperature. So if a temperature is changes from 70 to 60, then the output is will increase to maintain the set point. So now it's 64, and then it's keep increasing to 90. If the temperature goes to 64, 67, you can see that the output is will decreasing to maintain the temperature. So for now we have done our PID control blocks in the Siemens TIA portal. You can see on HMI. So this is the our HMI screen for visualization. So you can see the temperature is 53, our set point is 65, and the gain is 0.42, integral 11, and derivative is 2. If you want to use the manual output, you just click here the manual button, so the output become PID output become 0. So you need to key in your manual output to whatever you want. If you set 60, 50, then click OK. Then your manual output is 50, so that you can see on your screen the output is 50, which is we set by manually. So this is how it will work auto manual function in the PID control blocks. So for now we have changed to auto screen so that it will control automatically. So it will not use the manual output. You can see the values output values vary depend on the your temperature input. Okay, that's all for today. Thanks for watching my videos.